if you pass.
Hey there, Dr. Ray here, CEO of the Learning Liaisons, and in this video, you're going to be able to watch one of our recent webinar recordings with our math director, Anderson Duran, and this focuses on GK Math and Praxis Math. So go ahead and watch in this video where our math director, Anderson, goes through about 2 to 3 skills that you will see on your either Praxis Core Math or GK Mathematic subtest. He's going to break down and introduce you to one of our proven effective test-taking strategies when it comes to dissecting math word problems, and that's destination plan follow. So enjoy the video and make sure you like, comment, and subscribe to our Learning Liaisons channel.
Welcome to our free FTCE, GK and Praxis Core Math little webinar here. I know I have a different date here. That was a whoopsie, but before we begin, just want to make sure that we are all on the same page here. So before we begin, a few things. Yep, you're going to get access to the recording. We're going to upload it to YouTube this weekend. And so in the next slide, I'm going to show you guys how you can get access to that. Yep, absolutely. Ask questions. Remember, like, I'm here for you, not the other way around. I want to make sure we get through as many great questions as we can. So if that means that you want to understand every question by asking questions yourself, hey, completely okay. Because I'm pretty sure not everybody here is going to understand every single thing that I'm saying. So it's great to ask questions so that even the people that do understand it get to understand it even better. And those who are kind of stuck get to make that progress too. So again, ask away, ask away, ask away. The webinar is going to be just about an hour and a half. I do respect your time. So I'll make sure to try to get it down at 90 minutes. And obviously, no, this webinar is not going to prepare you for the whole test because we have over 20 skills on either exam, and I'm only going to present 3. So obviously, this is not enough, but it is going to be a good introduction as to where you can go from here and how to practice the right way moving forward. I know a lot of us have been here before, and give me a shout out if you have been here before in the chat box. If you've been to a previous webinar where we've learned destination plan follow, we've practiced and we've gotten that progress made. So booyah. I know we host these only periodically, but this is what it's all about, making that consistent progress, with the time that we have. So I'm really happy that we're all here. I'm happy that we're going to make this progress again today. And I'm glad that I could make a bunch of new problems that we're going to be uploading to our YouTube channel and our subscription channel as well. So just remember, guys, look, like, you got to take this test seriously. For the GK math, for the GK itself, only 39% of teachers pass in their first try. So, when it comes to these strategies that we're going to show you in the content, we're speaking from experience, and we don't want you to be a statistic here. So, at the end of the day, we're different from study guides simply because we don't trap you guys into memorizing solutions. I want to teach you guys how to handle every single type of question from start to finish. And that's going to be with my strategy destination plan follow. So we're going to go over that pretty soon as well. But lastly, make sure you have your phone camera out and ready to go. If you want to take any pictures, if you want to shout us out on Facebook, whatever you want to do, guys, I'm all for it. So again, like I said, before we begin, go ahead and subscribe to our YouTube channel, or just take a picture of this that we can go over later, and then subscribe so that you can get access to the recording when we upload it. So it's just the Learning Liaisons on YouTube. Simple as that. So before we begin, just a quick 10 seconds about me. I know there are some people that it's their first time here. So I just want to make sure that you guys understand a little bit about who I am, so that you don't just, see some guy who's sitting at his desk, thinking that you're supposed to trust him, but you don't know why. My name's Anderson. That's my first name. I'm the math director here, and I'm also the director of learning and development for the Learning Liaisons. And honestly, I keep saying it, but it's the funnest job ever, man. I get to teach teachers for a living. I get to help you guys succeed. And that's really what I've been dedicating my life to. So with that said, education background, I went to UCF for both my undergrad and master's program. Both of those were in math education. The master's program was a fancy curriculum and instruction, but math education. But yeah, I've made other courses and other materials for the SAT, the GRE, for AP Calculus on top of the GK and Praxis. So at this point in my life, honestly, it's just been so much fun being able to help people succeed. And especially since it's online, because I can spread myself out even further. So it's awesome. It really is. And some fun facts. I have a podcast. I tell terrible puns, and I got a healthy appetite for burritos. So in terms of like bad puns, hear me out. I just read a book about falling down a staircase. It was a step-by-step guide. All right. So with that said, we're going to go ahead and keep things simple here. We're going to go ahead and talk about the strategy that we're going to employ throughout this session. And it's destination, plan, follow. All right. So for those of us that are new here, I want to just remind you about some of the common tendencies that some of us make. So if it's fair to say, for some of us that are particularly nervous around math, is it fair to say that when you see a word problem, sometimes your impulse leads you to just look straight at the numbers and try to do whatever you can with those numbers to get an answer that's there, before you actually read the whole problem, before you actually process everything? Is it fair to say that sometimes your impulse takes over and you grab your calculator and you just start messing with numbers, right? And so the thing is, we want to control that impulse. That impulse comes from anxiety. It comes from not knowing. And the thing is, we want to be confident about what we're doing. So the first thing that we always need to do in any problem at all is to first understand what's going on, understand the context. And this is true for real life too. Anytime in real life where anything major is happening or minor, you ask, hey, what's going on and what is the actual issue? And that's how we want to tackle word problems here today. We're going to read it, and we're not going to read it to look at the math. We're going to read it to just understand the situation. And then we're going to just basically point out what we absolutely know. And then we're going to point out what we don't know or what we might need to know. By doing that, you're starting the problem out in a confident way because you're only starting off with what you know. I like to use this example recently about jigsaw puzzles. I don't know anybody here who likes to do jigsaw puzzles, but the easiest way to start a jigsaw puzzle, no matter what size it is to start off with the edge pieces. You start off with the edge pieces and then you collapse everything inside of it. And that's because there's that plan going in. You want to set everything up. You want to see the scope of where everything can go, and then you go after it. Same thing with problem solving. You kind of just take a step back, see where everything is, only point out what's easy, and then we're going to throw the math in. That's the next step, the planning step. So the first step, destination, is just about understanding the situation and pointing out the question. The plan is to understand what the question means and how to connect what we have to what we need to know. That's where the math comes in, because they always give you given information and they always give you a question. Your goal is to figure out how the math that you can figure out, works here. How does that math get us from what we know to what we need to know? That's the essence of the planning phase. Because once we understand that plan, how we're supposed to get from here to there, that's when we grab our calculators and then we follow those steps. So it's a 3-step process, short, sweet, and simple. Destination, plan, follow. You look at the context of the story, then you make a plan to go from where you are to what you need to know. Then you pick up your calculator and execute that plan. Because the thing is, at the end of the day, a calculator is a tool, and we don't use tools unless we know why we're going to use them. If not, then we're just going to go around in circles, not knowing if we've actually achieved our goal. So with that said, are you guys excited? Are you guys ready to go? Because I know it's not going to be super obvious in terms of how to use this at first, but that's what practice is for. So let's go ahead and get this going. I love the excitement. I love it. I love it. I love it. Let's go. Let's get some math. I'm going to get my calculator just in case I need it. Let me get my timer here. All right. So guys, every question I'm going to give 2 minutes and 15 seconds for these first 3. Then for the next ones, they are a little shorter, so I am going to shorten the time. But this first set here, 2 minutes, 15 seconds. 3, 2, 1, go. And remember, don't reveal your answer. Just type ready in the chat box when you're ready. Remember, we're not revealing our answers until time is up. We still have just about 1 minute and 15 seconds here. Great job so far, everybody. Looking at our final 30 seconds here. Remember, even if you're done, go back and convince yourself that what you did is right. We have that time here. Let's use it wisely. We're looking at our final 5, 4, 3, 2, and 1. What are our answers? What do we got? What do we got? What do we got? All right, looking like a lot of people are selecting D at first, but then we have some A's, B in here, but more D's, some more A's coming in. Okay, okay. Let's see who's left. We got a couple more people. And again, yes, be honest, be honest, be honest. If you did not see the solution moving forward. So be honest 100%, because I want to take you from where you are to where we need to be. And so by revealing where you are, too easy. Hey, if you know me at all, you don't ever want to say too easy in the beginning of a session. All right, so let's go ahead and let's review the question, because remember, I don't reveal the answer until I go over it with you. So here we go. The circle graph shown represents the annual budget for a company and is divided by department. If the total annual budget is $7,500,000, what amount is budgeted for support? All right, so when I read through this question realistically, I'm not going to read through it word for word. I like to read it and just get the words, and I ignore the numbers. So when I read through it, the circle graph shown, okay, boom, that's obvious. So the circle graph shown, it represents annual budget for a company. Okay, and it's shown by department. Okay, if the total budget is this much money, what amount is budgeted for support? So when I read that, for the first or second time, we have to quickly interpret that and say, okay, look, we're looking at annual budget and it's showing by department. I see total budget there, but we're looking for the amount budgeted for support. I clearly see here that that's 43%. And so 43% of what? Well, 43% of the total budget. So in our work here, our plan is to find 43% of the budget. And we're given that budget actually. So that's the cool thing. We're given the budget right here. The total annual budget is $7.5 million. So essentially what we're looking for here then is 43% of that $7.5 million. So far, before I continue here, are we good here in terms of where I've come from and where I've ended up at right now? I haven't gotten the answer yet, but up to this point, does this make sense? I read the question and we're saying, hey, look, we're talking about annual budget for a company, looking at the departments. We have the total budget and we're trying to find one of the departments. Sweet, no worries. So I see a couple of us are saying that we misread it, and that is perfectly okay. That's actually, I welcome that a lot, because again, it's about destination, plan, follow, interpreting the problem, planning the steps, and executing with a calculator or whatever you need to. So that just tells us that the destination, we had a little hiccup there. We probably would have gotten it right if we would have gotten or not missed that little hiccup. So, hey, this is good. Reveal where you are. So with that said, to find percent, remember, we need to convert that percent to a decimal. Everybody remind me, how do we convert a percent to a decimal again? Go, go, go. Let's see who got it. Divide by 100, exactly, Jamal. And essentially dividing by 100 lands us by moving that decimal place over 2 times. So it's 0.43. The word of translates to multiply, $7.5 million. And once we do that, everybody, well, we're supposed to get 3,225,000. That is 3,225,000 for support. And remember, at the end of a problem, you always want to go back and just reflect on it very briefly. That way you can say, okay, cool. This is what my answer means. I've made more of a connection with the problem and the process and the steps that I took and my reasoning behind it. And now I know that if I see a problem similar to this again, I am able to recognize what elements are really necessary to solve the problem. So with that said, the answer here is D. How are we feeling so far about this first one? Do you feel like this was too easy, fair, difficult? How are we feeling about this one? Yeah, and another way is to use a proportion. So if we're able to use a proportion in a coming problem, we'll definitely apply it so I can show 2 ways to do it. So Adriana, just to go ahead and go over it one more time. Yeah, so we get the decimal from a percent because here's the thing. When it comes to multiplying percents, you can't multiply a percent. You have to convert it to a decimal first before you can actually multiply it as a number. And so the thing is, when we have it like that, a percent is always out of 100. So this is 43 out of 100. And so 43 divided by 100 is the same thing as moving the decimal place over 2 times. You can grab your calculator just to double check me. You can grab 43 divided by 100. And next thing you know, it looks like the decimal place got moved over 2 times. Yeah, no worries. All right, everybody. So give me a yes if you're ready for question number 2. How many can we get? How many can we get? That's fast. All right, everybody. 3, 2, 1, let's go. 2 minutes and 15 seconds again. Destination plan follow, guys. You got this. We're looking at our final 15 seconds. Five, 4, 3, 2, 1. Let's go. What do we got? What do we got? What do we got? And be honest, yeah. So let's say, if you didn't get to an answer, hey, where'd you get stuck? Was it interpreting what you had to do? Was it making any math relationship or equation? Was it you think you made a mistake computing, ran out of time, whatever it is. Be honest, be honest, be honest. I want to know. I want to know. All right, no worries. Got lost in the steps, kind of lost. All right, sounds good. So let's go ahead and review it. So remember, as always, destination, plan, follow, guys, from start to finish. From start to finish. Destination, plan, follow. So here's how we're going to do it. Destination, I'm going to read the problem again. Remember, you don't want to talk about anything that you don't immediately recognize. So that includes numbers, and that also includes any math that isn't obvious. So the circle graph, you know, that's what I mean. Like, I'm not going to ignore circle graph because I know what a circle graph is, or a pie chart. I know what those are, so I'm not going to ignore that. But the circle graph shows how a family spends its annual income. If this much money is used for food and housing, combined, that's a key word I'm probably going to want to emphasize. What's the total annual income? All right, and I'm going to highlight the question in red here. So here's the thing. This is kind of like, you know, marketing in business. You want to make sure that you can get your message across as clearly as possible and as little words as possible. And when I read this, I'm saying, okay, looking at a circle graph, family spends its annual income according to the circle graph. Okay, so we have food and housing combined. We want total annual income. Boom. We have everything we need for this to get this done. Again, it's about picking out the most important pieces of information, or the ones that you can clearly recognize. So with that said, that's what I'm looking for again, total annual income. Well, the thing is, I know that the total annual income is the entirety of the circle graph. That's what the circle graph is. So again, total annual income equals what percent then? Right, so essentially, yeah, food, not food and housing, but the total annual income is 100%. If we're talking about the total annual income, that's 100% of their budget, because that's everything that they make, right? Now, the reason I did that, it's because there's something that we want to know about this. The total annual income, we want to know the dollar amount. And so with that said, we don't know how many dollars equals 100%. We don't know. Is it okay with you guys if I use T for total? Is it cool? Again, I don't want to use X. The more you use X, the more distracting it becomes. By using T, I know that T means total. All right, so cool. So the total equals 100%. I also see here that we're given food and housing combined. So I can say that for food and housing, again, this is for the total here. Now for food and housing, let me write down that information and let me see if I can figure out any sort of pattern or any relationship that I can make in the same way. But for this, I see that there's a dollar amount associated with a percentage. What's that dollar amount, everybody? Exactly, $51,600. Great stuff, guys. $51,600. And what percent is that associated with? Is that given to us, or do we have to do a little bit of work to figure that out? Or is it impossible to figure out? We have to add, correct. And here's the thing, everybody, remember, they're saying that $51,600 is used for food and housing combined. And I remember I highlighted that word because I'm like, I'm not getting tricked here. We're looking at a sum of something or a combination. So I'm looking at food and housing. Together, I'm going to add those percents. So 25 plus 18, that makes 43%. And so there it is. $51,600 amounts to 43%. Now, before I continue in terms of how I'm going to relate these pieces of information, I just want everybody to let me know, up to this point, do we understand the following things? Do we understand that we're talking about a family and how they spend their annual income? Do we also understand that the information that's given to us is requiring us to find the dollar amount for the total annual income? So we want to know how much they have to spend. All right, do we also understand that the combined percent for food and housing is 43% because we're adding the percents on that pie chart? Perfect. So that's all you need. again, we're looking for the total amount there. And we were able to show that, hey, look, if this is a pie chart and we're talking about percents, intuitively speaking, we should be thinking that the total is 100%. So that should be good. I was also able to see here that with the information that they gave us, food and housing together, we have a dollar amount and we have the percent. So it looks like we're comparing dollar and percent across both. So everybody, and if it comes to you easily or not, if you think about it for a bit, what kind of math do you think we might be able to use here? And there's multiple types of math we can use, but is there one that particularly stands out to you in terms of me saying that we're comparing two things in the same way? Now, what happens when we're comparing two items in the same way? Yes, I'm starting to see it there. Starting to see a pattern there. Need a couple more people to say it. It is proportion and ratios. I want everybody to type it in there. Exactly. Good job, guys. Yep, this is a proportion. So go ahead, everybody type it in the chat box. This is a proportion. It's a proportional relationship because, again, you're comparing the dollar amount to its respective percent on both situations. So we can create a proportion here and do this nice and smoothly. Here's how. I'm going to set up the relationship. As long as it works in terms of comparing the same way, you can set it up like 4 different ways. So watch this. We can say T over 100% equals $51,600 over 43%. That works out just fine. Just fine. You can also set it up like this. You can also set it up as T over $51,600 equals 100% over 43%. Both of these are just fine because in this case, we're going dollar to percent, dollar to percent. In the second scenario, we're going dollar to dollar, percent to percent. So everybody, just to do a quick check really quick, does everybody understand why this proportion is, or why either one is correct? Yeah, either one is correct. And if this is where you get lost, this is where we need to say, hey, I need to go ahead and do some proportion practice. This is what's going to indicate it to you if you don't understand the concept itself. And there is another way to do it with percent. So the first problem I did it with a percent, and this one I'm going to do it with a proportion. Yeah, so here we are. Let's just go ahead and cross multiply and divide, and we're good. So there it is. Cross multiply and divide, we're good. So 43T equals 100 times 51,600. So that's going to go ahead and give us 510 and then $5.16 million. From there, we'll divide both sides by 43. And that's going to give us what, everybody? T equals exactly B, $120,000. And remember that $120,000, that represents the total annual income. Total annual income. So $120,000 was the answer. So really quick, just a quick check here. Even if we got it right, even if we got it wrong, do we have a better sense of confidence about this type of problem, even slightly? And if so, in like 2 words or less, what about this are you more confident about? You can use 3 or 4 words if you need to, but just like short and sweet, what are you more confident about? You can say destination plan follow, you can say proportion, you can say doing it another way. Yeah, you guys would be surprised. Like proportions apply to a lot of problems. Yeah, on your test, officially, it's like 1 skill out of the 20 plus. But the thing is, you can use a proportion to describe a lot of relationships. Setting it up, destination plan follow. All right. Let's go ahead and dive right in. Let's keep it going, guys. Let's keep this math party going. A little stuck on this problem being a proportion due to the percentages. I love it, guys. I love it. So with that said, let's dive right into question number 3 here. Let's see if we can get this one done. So 3, 2, 1, go. Remember, guys, read the problem in its entirety, only picking apart what is relevant. And with more practice, you'll be able to recognize more easily what's relevant. So starting the timer now, I'll give us an actual 30 more seconds on this one. So almost 3 minutes here. This is a hard one. So I'll give us 3 minutes. Go. And again, do not reveal the answer until it's time. Still got about a minute. All right, look at our final 10. And remember, you're not penalized for guessing on the test, so don't feel bad for guessing. Don't feel bad. 3, 2, 1. What do we got? Go. Look at this. All right. All right. All right. I like you guys being honest. I really do. Man, it's a lot of sharing. Hey, I love it, guys. There we go. All right, so let's go ahead and review it here. Let's review it. Let's review it. Let's go ahead and do it. So, as part of a survey, 1,200 people were asked to name their favorite sport, where the table and circle graph below present the results. So if I'm reading that for the first time, again, I'm only looking for those keywords here. So I'm saying, okay, a survey, this many people were asked to name their favorite sport. Okay, cool. So this is about a survey for favorite sports. And the data is shown. Okay, cool. For the central angle X, okay, that's where I'm like, I don't want to get confused, right? So when I read this, for the angle, I can recognize angle. So for the angle, find the angle for the portion of the circle graph representing football. Okay, so find the angle representing football. That's what I got out of that. So guys, do you see what I just did there? I didn't read that whole question statement or that whole directive and say, I didn't get hung up on the X. I just backed out of that and said, what can I recognize? Find the angle for the portion of the graph representing football. I understand that. Does everybody see what I just did there? Yeah, even if you weren't able to do it yourself, that's completely okay, because this is what it's about. It's not just about X's and Y's and doing, algebra and arithmetic. This is about interpreting the keywords in the context. That's really what it's about as well. Because in every situation, they're not going to always, every situation that presents itself to you is not going to tell you what the problem is. Sometimes you have to figure out what the problem is. Sometimes you definitely do. So with that said, there it is. I have my direction. I want to find the angle that represents football. The angle that represents football. So with that said, what am I looking at here? Oh, there's a circle graph here, and I see that football is a bit of the entire thing. So if I'm trying to think about relevant information here, I want to know what this angle is, absolutely. But this angle is part of what here? What is this angle part of? Right, and what's the shape though? What's the shape? The shape is a circle, right? Now inside of a circle, the angle that makes up a circle from the center, exactly, it's 360. Exactly. So we have right here, what I can pull from here is say, hey, we have X out of 360 in terms of the degrees or the angle that we have. That's a relationship that we can say we have X out of 360. Now, here's where I'm going to go with this. I'm looking at this and I'm saying, I have that X out of 360. I'm looking at the given information here to see if there's anything that can help me out. And I see 1200 as a number pop up. But remember, everybody, it's not about what the number is. It's about what the number represents. So what does 1200 represent here, everybody? Quick. 1200 people, right? Let's go ahead and be a little more specific. What do you mean by people? Because we're talking about subsets of people. So 1200, like football people, soccer people, the total, exactly. Let's be specific there. That means total. So we have 1200 total. Is there anything else in this problem that we've already done that represents any sort of a total? Is there anything else that we've talked about so far? I'm trying to see if there's a relationship at all that I can form here. Amy, yep, there it is. Yeah, exactly, the circle, the 360 degrees. That is a total as well. That is a total too. And that's the football angle. Again, we've identified that X is the football angle. And so here we're talking about not the football angle and total angle. We're talking about football people over total people. That's what we're talking about in terms of making that same relationship. Yvette, boom, yes, is a proportion. It absolutely is. It absolutely is. Because we are comparing the same items in the same way. We're representing football over total. And it's the way that we do it that's different, but we're still comparing it in the same way. We're saying football people to total people, football angle to total angle. Are we seeing that, everybody? How that is definitely, clearly a proportion. Give me a yes. And even if you're looking at this saying, I hear you, but I'm still not sure how to solve a proportion, reveal that too. Because we want to be, again, honest about this, about where we are. Makes me proud, guys. Sounds good. So now we're going to go ahead and just set this thing up. So I know I have 1200. I know I have the 360, and I know I have the X. I just don't have the football people. But the great thing is it's actually given to us right there, 312. So with that said, we have a nice little proportion here that we can solve. And remember, guys, the easiest way to solve a proportion is cross multiplying and dividing. So with that said, we're going to have 1200x equals 312 multiplied by 360. And that is going to be, what's that going to be, everybody? Let me just confirm with my calculator. Help me out, help me out. I got 112,320. That's what I got. Yep, perfect. Thank you, Alyssa. And then from there, we're going to divide both sides by that 1,200, and we're going to call it a day. And we're all good. So X ends up being 93.6. Boom. Our guess was right, you guys. C's get degrees. That's what they always say. But, but there we go. So let me just reflect on this really quick, because I want to show you how 80% of the work, at least 80% of the work, is the planning. It's not the computing. It's not how well you can grab a calculator and press some buttons, guys. It's really about how quickly and swiftly can you develop your plan. Because again, destination, you look and survey the information, only picking up what you know, like caveman speak, really. Like you were talking like a caveman. What can you pick out and understand? And then from there, what is it that I need to do? What am I trying to find? And once you know what you're trying to find, then you make that plan. Given information, what I need to find, what's the math that's going to connect it? And when I think of math, math is all about making relationships. That's why when I looked at this, I'm saying, okay, I have X out of 360, so a part of a whole. Is there any other way that I can relate a part of a whole in this problem? And that's when I thought football people over total people. So, it's all about asking yourself, what relationships do I see? That's really what it is. Because once you make those relationships, then you can solve the equation that you make. But again, everybody, it's always about recognizing relationships, and that happens in the planning step. So on a scale of 1 to 10, how do we feel about this problem now? I love the honesty. There's a wide spectrum here. I love it. And so remember to think about what it is that you may need to do moving forward. Because if it's practicing the pure math itself, hey, go ahead and find that pure math practice. If it's the context, if it's the word problems that are tripping you up, boom, that's what you want to focus on. Taking it nice and slow at first, because the thing is, if you rush a plan, then you're going to be executing a plan that may be inherently incorrect. And so your answer is doomed no matter what. So the thing is, you shouldn't move past the planning phase if you haven't actually convinced yourself that you're good to go. Again, if you can't convince yourself, you're wasting time. All right, just move on to the next problem and then come back if you can. But with this practice that we have today, remember that the goal here is to push past and learn how to interpret. So we're going to give ourselves the entire time to interpret what we can. So with that said, who's ready for a new topic? Some of us got beaten down a little bit by circle graphs, and it's okay. It's all good. All right, so here we go. Next topic. Next topic coming up after this. Remember, keep things simple. Destination, plan, follow. What's the context? What's the content? And then let's go ahead and calculate. The 3 C's to problem solve. Destination, plan, follow. So before I continue, just going to go ahead and make sure that I remind you that we're sponsored by Pun World America. So here's our pun right now. Did you hear about the dyslexic zombie? He only eats Brian's. All right, cool. So coming up next, our next problem in 3, 2, 1, go. This one's going to be 1:45. And 5, 4, 3, 2, 1. Let's go. All right. All right, this seems to be a general consensus forming here with a C coming in strong. I got some B's coming in next there. Some A here and there, okay. No one's selecting D, which is a good sign. All right, let's go ahead and review it. So each member of a basketball team was asked to report the year he was born. Which measure gives the most common year of birth? All right, so when we read this, I want to just, again, go over it as if I'm reading it for the first time. Key words here. Each member of a basketball team report the year they were born. Nothing really special about that, but it does give me context. They're just talking about basketball players and the years they were born. Which of these measures? Okay, so which of these gives the most common year of birth? That's the key word right there. Because the thing is, we're talking about mean, median, mode, and range. And we have the phrase most common slipped in there. Everybody type it out. Most common refers to what? Everybody type it out. But what mathematical term? I know most means the most common. Exactly. Mode equals most. Mode equals most. Mode equals most. This is the mode. Remember, everybody, the mode is the term that occurs the most. All right. Mode is the term that occurs the most. All right. MO. Mode equals most. Exactly. Mode equals most. So with that said, this is a pretty quick one because you're saying, hey, which of these gives the most common? That's mode. Boom, done. And you're set. So with that said, even if we got it incorrect, are we good now? Are we good? Because this one's a quick one. You know, this one's just a standard definition that we need to understand and also be able to recognize in context. So once we have those two things settled in, again, that pure definition and how you can recognize it in context, you're good. All right, perfect. So let's go ahead, dive into question number 2. Same thing, minute 45, a little shorter this one. 3, 2, 1, go. Again, please don't reveal the answer until we're ready to go. I keep seeing like 2 or 3 people reveal. And that is perfect timing. 3, 2, 1, go. All right, looks like we have a lot of A's, some D's, but a lot of A's, but a lot of D's. There's a B coming in, a D again. All right, I'll wait a couple more seconds. There's a lot of answers coming in. There are a lot of answers here. Wow. All right, cool. All right, looks like we're good. So I'm gonna go over it here. In Dr. Mitchell's class, the 10 students had the following scores on the last semester test. And they listed the numbers out. Which of the following measures, okay, again, so same deal, guys. Which of the following measures, so which of these, should be used to summarize the data? So which of these best summarizes the data? So again, what are we talking about? We're talking about 10 students, the scores in the last semester test. Cool. So if I'm taking a look at the data here, if I'm trying to, say, hey, what is going to best represent it? You got to think about how things would be computed if you went about it, and how it would look. And if there's any effect that would kind of skew your data. And here's what I mean. What do we notice about all of these numbers? Is there anything that pops out to you? Okay, some people are saying it's similar, not in order, repeats all over the place, a wide range, repeats, majority are 130 something. Most are close to, okay, I'm gonna probe that one right there. So we're saying that most of them are close together. Okay, what do you mean by most of them are close together? Is there a value that's a little out of the way? Yeah, we noticed that, right? Notice how everything here, everything, it's between 130, it's in the 130s and 140s. Well, we have a 129 here, but that's okay. But for the most part, these numbers are all pretty close together. But then out of nowhere, we have 82. So here's the thing, everybody. Here's the thing. When it comes to representing data, if we're looking at data that's pretty close together, we want to represent it with the average, with the mean, because your mean is your typical value. It's like your center of gravity, quote unquote. And I know a lot of us have heard that phrase before, center of gravity. And so the thing is, when we're looking at a problem like this, we can use the center of gravity or the mean or the average to represent this data if and only if the data is pretty close together. That's not true here. It's not, because we have what's called an outlier. When we have an outlier, we cannot rely on the mean to show us that true center of gravity. Instead, we're going to have to look at the median. So there's the rule. I'm going to write that out for us. I'm going to spell it out for us. Here's the rule. So to best summarize data, again, if values are close together, so if they're close together, then you are basically saying that, hey, look, the average is going to be right there somewhere in the middle. So boom, you go with average or the mean. But if there's an outlier, so if there's an outlier, well, what that means is that the data is going to be skewed. That average is going to be tugged unfairly in another direction. So let me just go ahead and finish that off by saying, if there's an outlier, you're going with the median. And remember, an outlier, if you want to take a picture here, is a value that's like way out of the way, that doesn't look like it belongs in that data set. And so let me give a proper example here. Let me actually use green. Watch this. Let's say we have the following numbers. Let's go ahead and say we have, 99. Let's say we also have 102. Let's say we also have 103. Let's also say we have 97. So everybody help me out really quick. Can we take the average of these four numbers? Somebody help me out as quickly as you can. Grab your calculator, add these numbers up, and then tell me what the average is. I know there's like 20 people racing right now. I love it. Yep, 100.25. It looks like that's the consensus. That's 6 people that said that so far. So the average here is 100.25. And would you say that represents this little piece of data pretty accurately? Yeah, I would say so, because they're between 99 and or 97 and 103 and 100.25. That looks like it's the typical value. It seems like it's pretty close there in the center. Now watch this though. I'm going to use these same exact numbers. Same exact numbers. But I'm going to add the number, let's say 3. Everybody do me a favor. What's the average now? Same numbers, but now I'm including 3. So it's now 5 numbers, not 4 numbers. So we have to divide by 5 now, not 4. So what would happen if we take these numbers, added them all up, and divided by 5? What's the new average? Oh, look at that, 80.8. So think about that, guys. If I'm showing you this data here, and I told you, hey guys, if you picked out a random number, that number would probably be like 80 or pretty close to 80. But when you look at this, not a single one of these numbers is what I would call super close to 80. So do you see what I'm saying now, guys? It's really important for us to use the mean when the data is all bunched up together. If it's not bunched up together, even if there's one outlier, we cannot rely on the mean. So we're going to use the median instead. Here's why. Watch this. In this data set, look at this. What's the median going to be for the first one? What's the median here? It's probably between 99 and 102. So we have to add those up and divide them by 2. So what's that going to be? Hey, that's what you're here for. I'm here to help you guys out. So guys, help me out. What's the median going to be of this data set of the first one? What is the median going to be? Remember, the median is the middle 2 values here, added up and divided. When we have an odd number, we just look at the middle one. But what is the median? Let's order this. Not 102.5. Remember, we have to order them first, and then we take the middle 2. So it's not going to be 102.5. It's going to be, yep, 100.5. So look at here. If the data is pretty close together, the mean and median should be pretty close together. Again, the more uniformly distributed it is, like the more even the data is, the closer the mean and the average are, or the mean and median are going to be to each other. But now looking over here, after we added that outlier, look at the median again. So I'm going to order the numbers from least to greatest: 3, 97, 99, 102, 103. There's my median, 99. Again, does the median 99 represent the data here better than the average does in this case? It does, right? The median represents our data better than the average does in that case. So that's if there is a home run moment I wanted you guys to have today, it was this exact problem, because I was banking that the majority of you, and I was right. I was banking that the majority of you were going to select mean. I didn't expect range, but I did expect mean. And I'm happy that I was able to open your eyes, because I had a hunch that there was a little misconception floating around here in terms of how to select the best measures. So honestly, how are we feeling now that I've revealed this information? Is this something new to you? Is this helpful? Mind blown? Makes you feel better, very helpful. Perfect, guys. I really, there we go. I'm happy that you guys are finding benefit here. Because again, at the end of the day, we're going to make mistakes here. It's going to happen. But the goal here is to grow from these mistakes as quickly as we can, right? That's always the goal. So there we are. That's why B is the answer. That's why in this set, again, because there is an outlier, we want to go with the median because the median is going to represent our data better. Simple as that. So let's go ahead. Answer number 3 here from selecting the best measure. 3, 2, 1, go. I'm going to give us 1 total minute. Go. Got about 15 seconds. Yep, this is the question being asked. Oh my gosh. All right, so assume that the question being asked is, which of the following measures would best represent this data? That is totally on me for dropping the ball there. Thanks for pointing it out, though. Yeah, thanks for asking. I saw so many people say ready too. You guys are liars. So again, the question here would be, which of the following measures would best represent the data? Just like it has been for the past 2 questions there. So which of the following measures best represents this data? So 5, 4, 3, 2, and 1. What do we got? Which of the following measures best represents this data? All right, looks like a barrage of us are selecting A. We have some C's in here. All right, I'm gonna go with it. It's A. It is A. It's definitely A. And the reason is because, if we're trying to look at the measure that best represents this data, well, I'm taking a look at the data and what can we say about this data set, guys? Is it all over the place? Is it pretty concentrated? What can we say in terms of, what we're observing here? Right, they're pretty close together. Exactly. The values are pretty evenly spread out across a very clearly defined set. Here the lowest number that we see here is what, 37. I'm going to circle that right now. And I see that the biggest number here is going to be what? 47. So with that said, yeah, so they're only 10 apart, and yeah, they're all pretty much in that range. Like they're not like, leaning toward one side or another. It's pretty close together. And so with that said, if we're trying to represent data that's pretty evenly or normally distributed, hey, that mean is going to be our best bet for sure. So again, does everybody understand that? Write that down. Again, if it's close together, bunched up, that is the mean. If you have an outlier, median. And if you're looking for most common or anything that describes most common or favorite or anything of that nature, what is that again, everybody? That's it. That's the mode. Exactly. That's the mode. Lightning, lightning, lightning. Exactly. Boom. That's how we do it. And range would typically be, they'd ask you, hey, what's the difference between the tallest and shortest student in class? Or what's the difference between the biggest or smallest value? Whatever value means, whether it's height, whether it's, amount of money, whether it's salary, it doesn't matter. If anything is shown that's depicting a difference between the highest and lowest, that's range. So anything like that is basically comparing top and bottom. Comparing that is range. All right, that is range. Thanks, Melina. All right, so I'm gonna leave that up for a couple more seconds there, and then we are going to move in. We are going to move in. I'm trying to see which of these puns I want to say. So, all right, I got one. I just found out that my new electric toothbrush is not waterproof. I was shocked. All right. So again, guys, we're keeping things simple here, keeping things light. So again, destination plan follow. Sometimes it's going to be pretty intuitive in terms of what the steps are that you need to take, kind of like how we just showed with the previous set. But as many times as you need to do, as many times as you can, apply destination plan follow so that you can really exhibit that discipline to stay confident throughout the problem solving process. If we can't stay confident about the problem solving process, that's when our confidence breaks down. That's when we start making mistakes in terms of believing that we should take a certain step without actually validating it, without actually knowing why it makes sense. And so it's all about knowing why something makes sense, because it's going to drive your confidence, your decision making, and ultimately whether or not you get the question right. And we all know that you need to get the questions right to pass. So with that said, again, I need everybody to type out destination, plan, follow in that chat box, and then press enter. I'm typing too fast. All right, sounds good. Here we go. I got another pun ready for you guys after this one. 3, 2, you have 2 minutes and 30 seconds. Go. 2 minutes, 30 seconds. Remember, type ready when you're ready. Don't reveal your answer. Hey, Jesse, to answer your question there. So these questions are, in terms of the topic that we're showing, they're pretty standard in terms of test level. These are pretty standard. The thing is, it's all about interpreting the context. So although the math may be, super straightforward, it's more so about being able to interpret and what you're supposed to do with the math before you actually do it. So there are definitely tougher questions, but for these topics, this is typically how difficult they would get, or as difficult they would get. And we're looking at 3, 2, and 1. Let's get it. Oh, a lot of us are choosing A here. A lot of us are choosing A. Okay. 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 A lot of us are choosing A. Sounds good. All right. All right. All right. So. Bianca, no. I'm not saying you guys are wrong. I am simply maybe a little surprised or flabbergasted, if you may say so, you know? All right, so let's go ahead and get back to the math here. I'm not gonna judge anyone here. I'm joking, guys. Here we go. So we have a group of 200 adults that were asked whether they exercise and whether they're vegetarian. So here's what I got from that first sentence. I'm reading through it and I'm saying a group of adults asked whether they exercise and if they're vegetarian. What I picked up was group of adults asked if they exercise or are vegetarian. Again, caveman talk. Pick out the caveman talk there. Group of adults asked about exercise and vegetarianism. Results are shown. Okay, cool. That's obvious. The question, though, is not so obvious. The question states, what percentage? Okay, I'm going to highlight that right there. Percentage of who? Here's what is really going to trip a lot of people up, right? It's this language here. What percentage? Whenever you read a question that says what percentage, that word of is usually what's going to follow. So what we're seeing here is what percentage of these people are this. What that means is what percentage of, and this right here is your denominator or your 100%. And then this is the part that you're looking at. So what percentage of the adults that are vegetarian exercise? It's all about reading the question the right way. And there it is. Everybody just go ahead, go grab your mop. I know everybody's brains are on the floor. Go grab your mop right now. Just do it. And just clean that thing up and just think about what we did here. But again, I'm just joking around. But look, it's about the structure of the sentence here. What percentage of? Okay, cool. So it's kind of like, think of another example. What percentage of my annual budget do I spend on entertainment? So that's entertainment over 100%, over total budget, right? What percentage of these groups of adults exercise? So it's exercise over adults who are vegetarian. So that's what we're looking at there. And so with that said, again, vegetarians is in the denominator. Of the adults that are vegetarian, how many are vegetarians that exercise? That's what we're looking at. And so I can grab this over here and I can relate that to, in terms of, the percentages that I see, because this would be a 100% in terms of vegetarians. And vegetarians that exercise, well, I'm looking for that. I'll say E%. But what am I comparing that to? Well, if I have percents over here, I'm going to want to use real figures, like real numbers now. Here's the only thing, guys. We just need to make sure that we're comparing the same items in the same way. Whoever called out, Kim, you called it out earlier. I love it. Yeah, we can compare the same items in the same way. Every time we have a percent problem, we can always use a proportion. So with that said, let's look at these real numbers. The denominator is vegetarians. Again, that represents 100%. How many vegetarians do we have, everybody? Shani burst through the door with 90 and everybody else is following suit here. It is 90. We have a total of 90 vegetarians. The way that we find it is by checking it out right here. Vegetarians, that's the column. And so I'm going to add up the 63 and 27. Adding these two up right there, and we're good to go. So 63 plus 27 gives me 90. So we're talking about out of 90 people, out of all of the vegetarians, out of 90 people, Ugh, keeps bugging out on me. But yeah, and so we want to know how many of them are vegetarians that exercise. So fit vegetarians. I know that you don't have to be vegetarians, not trying to offend anybody, but I'm just going to shorthand that. Fit vegetarians. All right, cool. That's right there, 63. And so from there, I'm going to stop dragging this out. We're done. Just go ahead and cross multiply and divide, and we are good. So cross multiplying and dividing gives us 90e equals 6,300. Dividing 90 on both sides allows us to receive the E, or the exercise, out of the people who are vegetarian. That percent is 70%. So I know a lot of us right now are probably pretty heated or a little triggered, maybe some tears. I know, but do we see where do we see where we can turn that mindset in terms of, hey, what is the most important part of a word problem? It's not the math. It is reading the question. Can we understand that now? I hope that by now we've gotten through to our heads here. Give us another one, I dare you. Hey, it's not an hour and a half up yet, so we're good. We're good. All right, guys, we have one more here. We have 11 minutes left, so I'm going to dedicate the next, again, 2.5 minutes here, or 2 minutes, 15 seconds for the last question here. Then I'm going to explain it for the next 3 to 4, and then I'm going to wrap things up, and we're all set for the day. So who is excited for our last problem? Who's excited? If I would have, been growing up and someone would have told me that I'd be getting people excited about math and actually doing a pretty good job at it, that's what it looks like, I would be telling you you're crazy. Like, these moments right now these are special. All right, here we go. 2 minutes, 15 seconds. Go. Remember, type ready when you're ready, but for those of us that are answering a little too quickly, let's go ahead and see if we can use history to our advantage and convince ourselves that we're right. Guys, context is important. With me changing what you just see on the screen there, everybody should be going back. All right, we're looking at our last 10 seconds here. Let's make it happen here. 5, 4, 3, 2, and 1. What's up, everybody? Got some A's. And remember, reveal if you're confused too. Doesn't matter if you're confused. I want to make sure that you're being heard. 32% is what we are coming up to. I'm not saying, hey, Jamal, it's okay. Reveal what you got. Be proud of it. That way you can be open to seeing where we can improve. That's really what it's all about. All right, let's go ahead and go through it. I love it. Most of us answered here. So a movie club surveyed college students. The students were asked how often they go to the movies and whether they prefer horror or romance. Results are shown below. So I just highlighted what I'm like emphasizing as I'm reading. Because the thing is, you don't have time to highlight during the test and you don't have time to write everything out during the test. So I literally, when I read it, I just either double emphasize it like in my head or kind of just like whisper it really low underneath my breath. So it's like, all right, movie club surveyed college students. The students were asked how often they go to the movies, whether they prefer horror or romance. All right, and then when I read the question, what percentage of students, so remember, again, that key word there, percentage of what follows. Okay, here's my 100%. The students that go to the movies what percentage of the students right there. So of the students go to the movies 3 times a month or more. So in this case here, guys, what's my 100%? Like what percentage of the students go to the movies 3 times a month or more? Which one is the 100%? Students or the ones that go to the movies 3 times a month or more? Which one is the 100%? All right, so it looks like some of us are still, kind of half and half on this one, and it's all good, completely all good. I want to just see where we're at and kind of, get that heart, that pulse check there. So here's the thing. Remember, it's what percentage of, and then it gives you the denominator or your 100%. What percentage of the denominator is numerator? Which is the P% or whatever. So this is what we're looking at. So what percentage of everybody does this? So everybody referring to 100%. So what I mean here is what percentage of all of these folks do that? So we're saying out of all of the students, so what percentage of the students go to the movies 3 times or more? Do we see that, everybody? Do we see that now? Again, yeah, it's about how we read that statement. It's about how we read that question. And so I'm glad that I'm showing you these tough questions because I'm happy that a lot of you are seeing that what makes it tough is not what you thought it was. Like you thought it would be some complicated math, but sometimes it's really just how we read it. Cool. So that's what we're looking for. So out of students, how many watch movies 3 times or more? So with that said, I can set up a proportion. I can say the P% out of the 100%, again, 3 times or more from the total students. So over here on the right side, same thing, 3 times or more. But this is the percent side. So I need the actual numbers here. So how many total students do we have? Right, we have 300 students. Now, of those 300 students, how many of them were at the movies 3 times or more? Correct, 96. And we get 96, everybody, by looking at out of all students, again, so all students, so everybody, how many went to the movies 3 times or more? So that's just adding these two together, and that's what gives us 96. So from here, now we're confident, now we're good. We can cross multiply and divide, and we're all set. Because we're gonna have 300p equals, and that's gonna be 9,600. So P equals 32%. Boom. And that's what we've got. That's A, and we're all good. But Bianca, do you see why 300 is necessary there, right? We see that? Sweet. That's all that matters. Because again, we're going to make mistakes. It's about recognizing potential mistakes down the road. That's why it's important to make mistakes early and often so that you don't make the same ones later. So I'm going to tell this to everybody again. If you're having trouble owning up to saying, hey, look, I'm not that good at math right now, hey, then, that's the first step, admitting that you're making mistakes, because that's going to leave you open to finding out what they are and why they're wrong. It's really another way that we can approach math. There's one way of having someone just straight up teach it to you, and then there's the self-serving way of you working on your own. And the thing is, especially with us working online right now, it feels like a lot of us are working by ourselves. So when you do work on it by yourself, you just know that you're not alone, because using that strategy, destination, plan, follow, again, it allows you to figure out whether or not your mistake is interpreting the story, connecting the math to the information, or computing or calculating. That's the great thing about destination, plan, follow. So with that said, again, destination, plan, follow. I'll leave this up for 10 more seconds to allow everybody to take one last picture here. I mean, I'm not making it seem easy. I just pride myself in my communication, if that makes sense. Because the thing is, when it comes to teaching anything at all, you can't assume that people are already where you're at. I want to meet you guys where you are and bring you up as close as I can to where I have my understanding. And so again, teachers that can't or have trouble meeting their students or refuse to meet their students where they are, typically those are the teachers that no one remembers. So we have to make that effort as teachers to meet our students where they are. And for me, you guys are my students, and we're all peers. I know that. But when it comes to math, it just so happens that I have the experience that I have. I'm sure a lot of us here have the English experience or elementary experience, And so with that said, did you learn anything from this experience today, everybody? Honest pulse check. And type something that you learned today. What was the biggest thing that you've learned today? And it could be destination, plan, follow. It could be something else. What did you learn today? Read the problem properly, right? That is the key. Reading things appropriately and correctly the first time around. The outlier, what to do when you see outliers. I love that, right? Percentage, read the question. Percentage of, total versus part, right? Mapping out the problem. Measures cues. Yep, the outliers, realizing that you can't afford to make simple mistakes. One mistake in the beginning will cost you down the road. Guys, it's like building a house. If you make a mistake early on in building a house and setting up the foundation, guess what's going to happen once that house is completely built and then one little thing comes over? The whole thing gets knocked over, right? And so you need to make sure that the integrity of the house is secure. It's just verified before you continue. And that's why planning is so important. You rarely see anybody making a building these days by scratch. It's too complicated. So think about math. Plan it out just like architects do. You guys are the architects of your own passing score here. So just do what you got to do. It's destination, plan, follow. And so with that said, I'm glad that you guys, stayed until the end and really went through and learned everything that you could. Because until May 1st, we're extending our stay at home 50% off site-wide for everything. All right, everybody. And, this is truly for you guys. In terms of the 5.9, Jesse, we'll work on that pretty soon here because we're actually working on the 6.12 right now. So, if you guys are taking the 6.12, I am making a nice question bank and video solution set for it. It's going to have a couple hundred problems, and it's probably going to have 1 or 2 practice tests. So I want to get you guys excited for it. It's going to be a huge, new, awesome product for the 6.12. And so right after that, 5.9 it is. So, but with that said, again, everybody, look, we want to make sure that everybody here is safe, secure, healthy, and we don't want to stress you out, all right? You guys know who I am. You guys know that I am here to sincerely help you pass this thing on your next attempt. So with that said, I understand the struggle here, 50% off of everything. Do what you got to do. Follow the courses, ask questions, and pass once it's time. So if you guys have any questions at all, I'll be here for the next 5-10 minutes for any questions that you may have. I see some Q&A questions lighting up here. So I'll take the time to answer any and all questions. This also works for the channel as well. Remember, the channels have hundreds of problems and video solutions. I can type out the channel names and websites in here. It's When You Pass GK Math and When You Pass praxismath.com. So for the GK, it's When You Pass GK Math, and Praxis is When You Pass praxismath.com. Perfect. And now let's go ahead and answer some questions here. So Lynn says, on the GK math test, does it go in order of competencies? Yes, Lynn, it does. For competency 1, those are going to be the first 8 questions. Then the next 9 will be comp 2. Then the next couple of questions is competency 3, then competency 4. The number of questions for every competency is 8, 9, 13, 15 in that order. So 8, 9, 13, and 15. All right, so Bianca, any problems for this on the math channel? So Bianca, I'm actually going to be uploading this to the channel, this exact webinar too. And I do believe that we also have representations of data in the math channel. And if you're in the GK one, you're going to go to 4.1. So competency 4, skill 1, those are the representations of data. Yeah, you're welcome. All right, so Margaretti says, what if I have the year package and it expires this month? Is it any way possible for me to get an extension? Absolutely, absolutely. So go ahead and email right here, jampel@thelearningliaisons.com. That is Dr. A's direct email. Go ahead and just save that there. When it gets closer to expiring, probably within a week or a couple of days, just reach out to Dr. A and he'll take care of you, okay? He'll tell you exactly what we can do. So the 612, it is similar to the 5.9. So there are going to be some problems that I'm going to pull from the 612 into the 5.9 because the geometry section are very similar, almost like step for step. There are other sections like the algebra part, the standard algebra. There is the statistics and probability. What else? And I believe there was functions as well, and the trigonometry. So there is a lot of things that match up with the 612, and I'll be pulling all of it that works. And then I'll be filling everything else in that we haven't. So Pamela, if you go ahead and go to thelearningliaisons.com, if you need the package, do you mean the math package or do you mean like a GK bundle? Adriana, yeah, for sure. I'll provide the channel link right here. Adriana, do you want GK or Praxis? Because I actually just posted it right below that text that you had. So when you pass gkmath.com and when you pass praxismath.com. Boom. All right. And then Jesse says is the 612. Oh, no, get that. The 612 is similar. Yeah, like I said, the 612 is much more extensive because it covers calculus as well and discrete structures, which is also covered in 5.9, but not as extensively. No, every webinar is going to be different. My promise to you guys is that every webinar is different. I go over new problems and we are set. So Bianca, if you're using GK, that's when you pass gkmath.com. And if you are looking for Praxis, the 5733 or 32, when you pass praxismath.com. So Shawana, we're actually working on the core writing right now. So once we get a couple more days working on it, we'll be able to give you guys a solid timeline on when we're going to have it done. So yeah, core writing, it is coming up for sure. Yeah, Yvette, so go ahead and check out the links that we post in the groups. And there's going to be a follow-up email that you're going to get as well with this information, plus the links to join our other free webinars coming up. So for each specific course, for core math and GK math, these webinars are happening like every 2 to 3 weeks. And we have a 612 webinar coming up at the end of the month. 612 is much more comprehensive than the 5.9, the SOC. Thanks, Dr. A, for posting those. I appreciate that. Perfecto. Let's see if we have any more questions here. All right, looks like everybody's questions are answered. And if anybody has any other questions, please let me know. Anybody who's still here who is willing, go ahead in our Facebook group, on our Facebook page, like the actual page, not our group, on the page, post and let us know how we did here. Be honest. If you loved it, if you enjoyed it, be detailed so that other people have the opportunity to get this free help just like you did. Effort is free. So I'm hoping that we can all come together as a community and help this thing happen for more people. Please and thank you. Please and thank you. All right. That's all I ask in return. I'll give you guys an hour and a half. All I ask is 2 minutes. Please and thank you. Yeah, thank you for showing up, really. You guys, it's not easy to want to continue making progress, especially during a time like this. Not easy. So I really do appreciate y'all for that. Appreciate you. All right, guys, I'm going to hang out for the next 2 minutes here. Hey, for sure. Yeah, you're welcome. So I'm going to stay here for the next 2 minutes. I'm going to close the room down pretty soon here. So please go ahead, see yourself out. You can hit leave meeting if you'd like to. I will be closing the room in just about 2 minutes. Yeah, be safe. Be safe. You're welcome, Bianca. I'll see you guys in the Facebook group. And remember, keep posting puns.